Balancing chemical equations, part 2. Okay, so we are going to start by looking at what we need to balance chemical equations. If you recall from the first set of notes, we talked about you would balance a polyatomic first, then all other atoms except for hydrogen and oxygen, leaving hydrogen second to last and oxygen dead last. Again, this is just a recommended way of doing it. It's not the only way of doing it. So remember, our list would be polys, all other atoms that aren't part of the polyatomic, then hydrogen, then oxygen. Okay, so we do have polyatomics. Remember, a polyatomic is 2 or more atoms acting as a unit. So we're going to put at the arrow NO3 because that's NO3 is on both sides. The polyatomic must be on both sides to use it. And we're going to say there's 1 because there's no parentheses, and there's 2 of these because there is a set of parentheses with the 2 followed by it. Then we're going to list anything else that's not part of the polyatomic. If there was a hydrogen or oxygen that wasn't part of the polyatomic, they'd be second to last and dead last in our list. So you see that you have 1 Cu and 1 Ag. On the right-hand side, you have 1 Cu and 1 Ag. Okay, so to balance this, we can only put numbers in front. Remember, this is our results area, not our thinking area. We go up here and say, what can I put out in front to make this turn to 2? If there was 1, I can put a 2 here. That changes my NO3 to a 2 and my Ag to a 2. So now I got 2, 2, 1, 1. Those look good, but my Ags are not, so I got to put a 2 here. And all I'm doing is fixing it down here to make sure everything looks balanced. Okay, we're going to skip this example and come back to it. Okay, I'm going to suggest that you pause the video and jot this down and try these as I'm going through them. Okay, so hopefully you pause the video and you're back. We're looking for polyatomics. I see a polyatomic here, and I see the same polyatomic over here. So I can use that as a unit. That should help speed things up for balancing. So SO4, Al, Br, and H. Notice I put H last. I did that because I do not want to start with H. I want to end with H. Most of the time that makes this easier to balance. Okay, over here, SO4, there's no parentheses, so I have 1. On this side, SO4, there's 3 because of the parentheses. 3, the parentheses say I have 3 of what's inside the parentheses. I have 1 aluminum, pardon me, on this side. I have 2 aluminums on the right, 3 bromines and 1 bromine, 2 hydrogen and 1 hydrogen. Okay, so we're going to start with balancing our SO4s. So they're 1 and 3. So I'm going to put a 3 over here. Sorry about that. A 3 over here, right? Now that changes everything. So I think of that multiply through. So this goes to a 6. Hydrogen will go to a 6 because 3 times 2. And I think of 3 times this 1. This will go to a 3. Because that's the same thing, by the way, as writing this out. If I put a 3 there, that would be the same thing as representing it 3 times. So when I put a number in front like I did here, now I have 1, 2, 3 of these, then you can count. You have 3 SO4s, you have 2, 4, 6 hydrogens. So if that helps, you can look at it that way also. Okay, all right. So we've got sulfates balanced. Now we're going to balance aluminums, 1 and 2. So I'm going to put a 2 here. What that changes is both those. It makes me have 2 ALs and 6 BRs. Okay, remember that if there's a 2 in front, that's the same thing as saying I have AlBr3 and AlBr3. So that's how I get the 2 aluminums and the 3 plus 3, 6 bromines. Okay, so aluminums look good now, but we did mess up our bromines, so we're going to fix our bromines. We got to put a 6 here. So I put a 6 here. It changes both of these. Remember, that would be the same thing as saying 1, 2, 3, 4, 5, 6 of these. So when I put a 6 there, it's having 6 total in the list if you want to think of it that way. So there's 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 bromines. If you need to, pause and rewind to listen to this again. Okay, so we have 3, 3, 2, 2, 6, 6, 6, 6. It is balanced. I would read this to you if I was reading it out loud as a 3, 2, 6, 1. We do not write ones, but you may be asked to do that in Schoology just because I have no choice in that platform. So normally we would not write a 1 here, and we won't in practice, but you might need to do that when doing an assessment or a practice in Schoology. Okay, this example now, I have this polyatomic and this is a polyatomic. I have this polyatomic that matches. I don't have an OH, but one thing you should know is you can always write water as HOH. So now I have OH polyatomics, and I have PO4 polyatomics. I have aluminums left and hydrogens left that aren't part of these polyatomics. Okay, so as I look at this, I say that there are 3 hydroxides and 1 hydroxide. 3 outside the parentheses says there's 3, no parentheses says there's 1, no parentheses here for PO4, so 1, no parentheses around PO4, so 1. I have 1 aluminum and 1 aluminum. I have 3 hydrogens and 1 hydrogen. 3 hydrogens here, and this hydrogen right here, we didn't count for it. We counted for it after we wrote it as water, HOH, we could count for it there, so there's 1. So the first thing I'm going to do is balance my hydroxides, my OHs, by putting a 3 here, which makes this go to 3. Think of it as 3 times 1 goes to 3. 3 times this 1 goes to 3. Okay, or you can think of it as, technically, remember, this is really this. We don't write it this way, but this is really what it is. So that's how I get the 3 times 1 is 3 and the 3 times 1 is 3. So 3, 3, 1, 1, 3, 3. Let me try that again. 3, 3, 1, 1, 1, 1, 3, 3. It's balanced. I would read this as a 1, 1, 1, 3. We will not write ones in practice, but you may be asked to do that in Schoology because it's a placeholder. All right, here I have NH4, a polyatomic, but there's no NH4 over here, so I won't be able to use polyatomic rule to shorten my work. Instead, I'll have to do individual atoms. So N, Cl, and H. Remember, H is last if it's present. Oxygen is dead last if it's present. So over here I have 1 nitrogen, 1 chlorine, and I have 4 hydrogens. Let me show you how I get 4 total, because I have 3 from this piece plus this 1. That's how I get my 4, because they're on the same side. As the symbol says, we will add them. Over here I have 1 nitrogen, 1 chlorine, and 4 hydrogens. Just like on part 1, you will have to tell me that it's balanced if it doesn't have any numbers. And you would read this off as a 1, 1, 1. We'll come back to this one. These are the harder ones, this one too. All right. Here we go. We have a polyatomic that's the same on both sides. So we will treat the polyatomic as a unit. We have aluminum and we have lead. We have 2 nitrates and 3 nitrates, 1 aluminum, 1 aluminum, 1 lead, 1 lead. Let's go through that. Where do I get this 2 from? Because of the parentheses 2. I get 3 because of this, 3. Aluminum is a 1. Aluminum is a 1. Lead on the left is 1. Lead on the right is 1. So nitrates have 2 and 3. Smallest number that 2 and 3 can go in are 6. You can recall this from the first practice. So we're going to have to put, if this side is 3, we got to put a 2 here, which remember that's the same thing as rewriting this twice because of the 2 in front. So that's the same thing as saying I have 2 aluminums, right? And I have 3 plus 3, 6 nitrate groups. Okay. All right, so I'm going to fix the nitrates on this side. That was the one we were working on. I had to get them both to a 6. So I'm going to put a 3 here, which makes this go to 6, and my leads go to 3. Remember, when I put this here, it's like writing this 3 times, and you would count 2, 4, 6. That's how I get 6 nitrates. Aluminum is 1 and 2. To get aluminum to be 2 on both sides, I'm going to put a 2 here. This goes to 2. And then lead is 3 and 1. To get 3 leads on the right, I got to put a 3 here. And there we are, we're balanced. That's a 2, 3, 3, 2. Again, I suggest that you go through these examples, pause as needed, rewind as needed. You are going to be expected to be able to do this on your own and take a quiz over it. Okay, next example, we have some we're going to go back to. Again, you should be pausing the video, jotting these down, and putting them as examples in your notes, or listening to this as practice. So we don't have any polyatomics, so we're going to just list our atoms. It doesn't really matter what order if there are no hydrogens or oxygens. We have 1 Cu, 1 I, and 2 Brs. 1 Cu, 2 Is, and 1 Br. So I got to fix my Is first to put a 2 here. What that does is that changes this to a 2 and this to a 2. So then I need to balance my Cus. I put a 2 here. That goes to a 2. And it also changes Br. Remember, that's the same thing as writing this twice, just as this was the same thing as writing this twice. That 2 says 2 of that unit. That's how I got 2 Cus and 2 Is, 2 Cus and 2 Brs, and it's balanced now with a 1, 2, 2, 1. Okay, here I have polyatomics that I can use. SO4 as a unit, A, L, Cl, and H. Remember, H is present, but I'm going to leave it to the very end. 1 SO4 and 3 SO4s, 1 aluminum and 2 aluminums, 3 chlorines and 1 chlorine, 2 hydrogens and 1 hydrogen. Let's go over that. So no parentheses for one, so 1 SO4, 3 SO4s because of the parentheses, 1 Al over here, and 2 Als over here, 3 chlorines over here, 1 chlorine over here, 2 hydrogens on the left, 1 hydrogen on the right. So the first thing we're going to do is balance our SO4s. We're going to put a 3 here. That makes, remember, 3 times this. So my hydrogens go to 6, and my sulfates go to 3. So then those are balanced. I'm not going to mess with my hydrogens. You could. I like to go down the list most of the time. So I'm going to put a 2 here to get my aluminums balanced. But that also changes my chlorines to a 6, because remember, 2 times 1 is 2, and then 2 times 3 is 6. So I have 2, 2, 3, 3, 2, 2, and now I got to get my chlorines balanced. My chlorines are here. I put a 6 there. It happens to fix both of these. 2 times 1 is 6. 2 times 1 is 6. Okay, so that balances that as a 2, 3, 1, 6. Okay, SO4 again as a unit. I must have liked this one when I made up these examples. It's not the only polyatomic though. And then we have aluminum, barium, and chlorine. We have 3 SO4s and 1, 2 aluminums and 1, 1 barium and 1, 2 chlorines and 3 chlorines. So the first thing we're going to do is we're going to work on our SO4s. We need to get them both to a 3. So I'm going to put a 3 here, which makes this go to 3. Remember, this is really what this looks like, right? So 3 times 1 is 3, 3 times 1 is, barium changes to a 3. So my sulfates look good, but I got to get my aluminums fixed. I got to put a 2 here to fix my aluminums. It makes my chlorines go to 6. Okay, 2 times 1 is 2, 2 times 3 is 6. My bariums are unbalanced. I got to get it to barium to a 3. Put a 3 here, which makes this go to 3. And my chlorines go to 6. 3 times 1 is 3. 3 times 2 is 6. Okay, next example. I have no polyatomics, so we're going to go back to Na and I. I have 1 Na and 2 Is, and there's a typo on this one. This should be NaI. And then this should be 2 Is and 1 I, 1 Na, 1 I. So let's go through that again. Add that I there. That was my typo. 1 Na and 2 Is on the other side, 1 of each. To balance this, I got to put a 2 here, which makes this side go to 2 and this side go to 2. And then I have to put a 2 here to make my Na go to 2. This is a lot like examples for balancing equation part 1. Okay, here we have no polyatomics, so we're going to list our atoms. Oops. We have 2 N's here and 2 O's, 2 N's and 1 O. So we're going to put a 2 here, which makes my N on this side go to 4 and my O's go to 2. So I've got to fix my N's on this side by putting a 2 there. I have 4, 4, 2, 2, and it's balanced as a 2, 1, 2. Okay, next example. I have a polyatomic here. Even if I wrote water as HOH, this is an example of when it won't work. So if you balance by polyatomics and you find some difficulty in it, you might want to just go back and do regular atoms. So because I have hydroxides, that would be great, except this oxygen, if I treat the hydroxides as a unit, I would have nothing on this side to off-balance this oxygen. So if you have a polyatomic and you have an atom that doesn't match, you're going to have to do it individually. So Mn, H, and O. We have 1, 7, and 7. We have 2 MNs. We have 2 H's, and we have 8 hydrogens. So we're going to start with Mn. This is 7, so you're clear. So we're going to start with Mn. We're going to put a 2 here. That makes this go to 2, this go to 14, and this go to 14. Okay, so then we're going to fix our H's. To get H's to 14, we got to put a 7 here, which is 14. And then my oxygens are going to be 7 from this part plus 7 more, because there's a 1 here. So 7 plus 7, this goes to 14, and it's balanced as 2, 14, 14, 2, 2, 14, 14, 14, 14, and I balance as a 2, 1, 7. Okay, continuing on. This example here, we have no polyatomics, so again, we'll do S and O. We have 1 and 2, we have 1 and 3. Got to get both my oxygens to 6. because sulfur looks good. So I put a 2 here. That makes this go to 6, but it also makes sulfur go to 2. So I got to get sulfur to 2. Yep, put a 2 there. And oxygen needs to get to a 6. So I need to put a 3 here, and I have 6. So 2, 3, 2 would be what you would need to balance. Next example, again, have no polyatomics, so H and O. I have 2 of these and 2 of these. I have 2 hydrogens and 3 oxygens. See where I get 2 hydrogens and then 1 plus 2 oxygens. So I'm going to have to get my oxygens balanced. I'm going to put, this is a difficult one. This guy is going to make this side odd unless I put a 2 in front. So now I have 4 oxygens and I have 4 hydrogens. So if I put a 2 here, I would have 4 hydrogens and 4 oxygens. Okay, so you might look at that one again and listen to that one again so you can see it. The trick here is to make the piece that makes the side odd every time, because 2 plus an even, even number plus an odd number is going to make it odd. 2 plus 1 is going to be 3, for instance. So I need to make this even by putting a 2 in front. Okay, so here we're going to balance no poly. So K and Cl, we have 1 and, oops, we have 1, we have 1, and we have 2. So I'm going to put a 2 here to get this to a 2, but it also changes that to a 2. So I got to put a 2 there to get that to 2. Okay, here we have A, G, and O. These are the simpler ones. We're going to go back to the more difficult ones in just a moment here. So I have 2 and 1 and 1 and 2. So I need 2 AGs. I'm going to put a 2 here. And I need 2 oxygens, which makes this go to 2, and it changes this to a 4. So notice when I put that 2 there, my Ag goes to 4. Well, remember, this is balancing, so I don't have to keep anything. I just need to change this number to a 4, and then I'm balanced for a 4, 4, 2, 2. Again, if this is too fast or too quickly, you may need to listen to this a couple times, because you can't, unfortunately, ask me questions in the middle of this. So Si and Cl. 1 and 4, 1 and 2. So I got to get Cl to 4 by putting a 2 here. So this was 1, 1, 4, 4, and it's balanced as a 1, 1, 2. Okay, so now we're going to go back and we're going to go through the more difficult ones. Again, you may have to listen to these several times. If you're doing this and you're struggling through these, please do not hesitate to email or get on a conference call with me so I can work on some with you one-on-one. Okay, so this is considered a combustion problem. How do I know it's a combustion problem? Because it's going to start with a hydrocarbon, just like the name says, hydro, hydrogen, carbon, carbon. So if it has this setup, a hydrocarbon plus an oxygen, you're going to balance C, H, and O. You're not even going to look for polys. Okay, and I do these separately because these are more difficult. When you have a combustion, you want to balance carbon, hydrogen, oxygen, and here's how you will do it. This will be a little different than the other method I just taught you. You have 8 and 18 and 2. You have 1, 2, and 3. So 8, 18, 2. Carbon is 1. Hydrogen is 2. Oxygen is 2. Plus this one, that's where I get the 3. So on a combustion, you're going to balance carbon first by putting an 8 here. I know that changes oxygen, but leave oxygen till dead last on a combustion. Completely at the end. Don't touch it until the end. Hydrogen has 18. I got to put a 9 here. So now I'm going to make this go to 18 because 9 times 2 is 18. So now carbon is good and hydrogen is good. Now I want you to look at oxygen. I want you to look at this part of oxygen here, okay? And I want you to see 8 times 2. From this, I get 16. And this part of oxygen here, I get 9 because remember there's a 1 here. So from here, I get 16. From here, I get 9. So in total, I'm going to have 25 oxygens I need on this side. Let's look at that again. 8 times 2 is 16. 9 times 1 is 9. 16 plus 9 is 25. Now I need 25 on this side. Now I'm going to put a number here that gets me to 25. But no matter what, I have to multiply that number by 2. So I need to think about what number should go there. Well, what's half of 25, right? Because whatever, if I have to multiply the number by 2, then if I divide 25 by 2, I'd know my number. So take your calculator and take your total, divide by 2, and you'll get 12.5. However, so now technically it's balanced. However, you are not allowed to use fractions or decimals in a balanced equation. So you're going to multiply what we call the coefficients, if you remember from our definitions, all by 2. Remember, there's a 1 here. We just never write it. So this is going to become 2. This is going to become 25. This is going to become 16. And this is going to become 18. Okay. You might want to rewind that list again, but we're going to do a couple more like it. So let's go forward. I still am assuming that you're pausing and jotting these down. Here's a combustion. How do I know it's a combustion? I have a hydrocarbon, hydrogen-carbon piece plus an oxygen going to CO2 and water. I'm going to do CH and O. I have 7, 14, and 2. I have 1, 2, and 3. Let's recall again. 7, 14, 2, 1 carbon, 2 hydrogens, and 2 plus 1, 3 oxygens. So on a combustion, remember, you're going to do carbons first, hydrogen second, and leave oxygen till the very, very, very end. So I'm going to put a 7 here, which gets my carbons to 7. I'm not going to deal with my oxygens. I'm going to leave them last. I'm going to get my hydrogens to 14 by putting a 7 here. This has 14 now. Now I'm going to deal with oxygens. So I'm thinking about that. That gives me 14. I'm thinking about this. Remember, there's a 1 here. That gets me 7. 7 plus 14 is 21. So I know that if I take 21 divided by 2, I'm going to get 10.5. 10.5 would get me to 21, but I can't leave the 10.5. I got to multiply everything through by 2. Remember, there's a 1 here. So this goes to 2. This goes to 21. This goes to 14. And this goes to 14. Continuing on, let's do this next example. It's a hydrocarbon. It's a combustion. Hydrocarbon because it has carbons plus hydrogens in the formula. So CH and O, 4, 10, and 2, 1, 2, and 3. Do my carbons first, 4. Do my hydrogens second, sorry. That's 10. 4 times 1 is 4. 5 times 2 is 10. Now deal with my oxygens. Thinking about that piece, I have 8. Thinking about this piece, 5 times, remember there's a 1 here, I have 5. So I need 13. So I need to get 13 on this side. So I need to put 6.5 here. If you don't know that number, take your total over here, divide by 2. Now multiply everything through by 2. So this becomes a 2. Remember, you always have to multiply that first part by 2 also. This becomes 13. This becomes 8. And this becomes 10. Okay, another combustion. We have carbon, hydrogen, oxygen. How do I know it's a combustion? Hydrocarbon plus oxygen making CO2 and water. 4, 8, and 2. 1, 2, and 3. Again, 4, 8, 2. 1 carbon, 2 hydrogens, and 2 plus 1, 3 oxygens. So I'm going to do my carbons first. 4. My hydrogens next. Gets me to 8, because I'm thinking about 4 times 2. And now my oxygens, I got to figure them out. Don't look down here. Got to look back up here. We have 8 plus 4 more. 8 from here, 4 times 2 is 8. And remember, there's a 1 here. 4 times 1 is 4, 8, 9, 10, 11, 12. So I need 12 on this side. So I need to put a 6 here. No need to multiply through by 2 because I have no decimals or fractions. All right, that concludes the notes for this part of our unit. Again, if you are struggling, you try a couple, you're not getting answers, please reach out to me. I can do a conference with you or you can email. I'm here to help you. Videos to help you balance. Have a great day. Thank you.